Hi everyone, welcome to this episode of Keipert Labs. Trying out a bit of a different video technique here, so I'd be keen to know your thoughts. And so the topic of this video today is speed versus velocity. Okay, so these are two words that you may well have heard in relation to how fast something's going on. Thinking about motion. So we've talked about this idea of how far, so speed being how far an object goes. Okay, so how far an object travels over the time that it travels. Okay, and so we've looked at this idea of speed equals distance divided by time. We've done calculations to that effect, rearranging this and to try and find out which of these three things that we don't know. But essentially this is the relationship we've looked at, So if a car is travelling at 80 kilometres per hour, we're saying that for every hour that it travels, it will drive 80 kilometres of distance. If we're saying that Usain Bolt, runs at 10.5 metres for every second, that is, for every second he is sprinting, he will cover 10.5 metres of distance, okay, which is an insane amount of, an insane distance when you think about it. Okay, but so we've often used these terms, and perhaps we've used them interchangeably as far as when we're thinking about, you're talking about velocity, then we're talking about speed, and then all of a sudden then we might be talking about velocity again. And what I really want to unpack for you just quickly is this idea that for physicists, these two things are similar, but not the same. They're not interchangeable words, and there is a key difference between them. Okay, so if we're thinking about, say, let's say we're thinking about a car. Okay, so you can see my kind of illustration of a fairly rubbish kind of Simpsons car sort of equivalent here. Okay, so say you're thinking about a car that's driving. Okay, now, one of the things about this car that's driving, there's two bits of information that we as physicists want to know. And that is, how fast, that is, its speed. That is, how far is it travelling, for every second that it travels. And the other thing that we want to know is its direction. Okay, so an object that's travelling has both speed and direction. Okay, so maybe it's travelling 80 kilometres per hour north, as opposed to a car that it passes the opposite way going 80 kilometres south. Now, for lots of situations you've encountered so far, that hasn't made a difference to you. It's not particularly important about which direction that it's travelling. But I want you to kind of imagine, let's say we have, this car, okay, that's travelling and it's going this way, and then it encounters a different car, travelling this way. Okay, and they both are travelling at 80 kilometres an hour. But you can see that they're travelling in opposite directions. And so we can't say, okay, well, car A, let's call this one A, and this one B. Car A and B are both travelling 80 kilometres an hour. Okay, that is true. That is their speed. But we might be caring about the fact that they're about to crash into each other, and what happens after they crash? What is going to happen to the wreckage? Where will we find it? Okay, the fact that they're travelling in opposite directions when they collide is going to greatly affect what happens during that collision. What happens to the people who are driving? What sort of forces are they going to experience? Okay, so each car has a speed and a direction. So if this one was travelling north and this one is travelling south, then we want to know that information. Okay, and so for us as physicists, we have a property of an object that's moving that does combine or kind of connect these two things together. And so this combination of speed plus direction is what we call the object's velocity. Speed combined with direction gives us velocity. So, e.g., 80 kilometres per hour north, 4 metres per second west. Okay, that's information that we might find useful. Okay, or perhaps it's 10 metres per second at 105 degrees. We might actually be describing a direction in terms of the degrees that it is away from true north or something like that. If you are in a boat, for example, that you might want to be describing the heading, the way that the boat is going. Okay, because all of this is information that's valuable to someone studying motion. Okay, so velocity is a speed plus a direction. Okay, but sometimes we can also express it a little differently. Okay, so sometimes when we're thinking about an object's velocity, we're only thinking about motion in 2 dimensions. Okay, so that is, or even, so is it moving this way or is it moving that way? Is kind of all that we are particularly interested in. Okay, or perhaps it might be, is it going up or is it going down? You can imagine for someone who is skydiving, or someone who's been shot out of a cannon, the difference between going up and down is definitely going to affect what you do, or what forces, or what you're going to experience. Okay, and so often what we would do, if we've only got 2 directions, the way that we tend to get around that, or that we can help quantify that mathematically in a way that's simple, is that we assign each direction either to be positive or negative. So rather than having to say like north or west or 105 degrees or that sort of thing, we can say that perhaps we've got a velocity of plus 10 meters per second. I realise it's just gone off the screen there. Okay, so plus 10 meters per second. Or we often say when we're thinking about the Earth, we're thinking about the concept of gravity, that up is positive and down is negative. So often we think about gravity, the force of gravity, acceleration due to gravity being minus 9.8 normally we would say, meters per second squared, which are units for acceleration. We'll get to that in a subsequent video. But we would give it a minus value to express the fact that it's pulling an object down back to Earth, as opposed to going up against gravity. Okay? And so for an object, we talk about its speed, how fast it's going, or that is how much distance it covers in a given time. But we also want to know its direction. We can connect those 2 ideas together in describing its velocity, and that there are different ways that we can express knowledge about the direction of an object. And one of the ways that we're going to experience is that using positive and negative to describe 2 different directions in the same kind of plane, left or right or up or down. All right, thanks very much for watching. Bye for now.